All right, so we're still looking at matter, and what does matter make? What does matter make? Huh? It makes up anything that takes up space. Okay? Does it make up Lauren? Does it make up that book? Does it make up air? Yeah. Okay? Because anything that takes up space has matter in it. What's the matter? What is matter? Okay? Matter consists of what? What makes matter itself? Well, that's density. Mass and volume make density. But what makes matter? It has to be a tangible substance, right? Well, what do we know that are tangible substances that can make up matter? What's contained on the periodic table? Elements. So all matter is made of elements. And those elements combine to form millions of different substances, but it's basically the only thing that can make up matter are those elements that are on the periodic table. Matter is anything that has mass and takes up space, what we defined earlier. So we're doing good. We've remembered that. Okay? Between the Quizlet and 3 days worth of covering it, we're doing good. Matter makes up the materials around you. Everything around us is made up of matter. Everything is made up. Light, sound, and energy, however, are not matter because they do not have mass or take up space. Now, this is a confusing thing I have seen on the test. Because sound, people think of it as being made up of molecules. It's not. Sound is the vibration of the molecules in the air already. Okay? Light. Energy. Electricity is not matter. It's the electrical current flowing with the electrons in the element itself. The flow of that. The magnet is made by the current inside the magnet's electrons. That's why you can take, some of you may have seen it, if not, you can go home and ask Dad about it. You can take a screwdriver, plain old screwdriver, you don't have a magnetic one, and you can cross it on a battery and shock it, and it will become magnetized because it changes the polarity of the electrons. And you can take a non-magnetic screwdriver and turn it into a magnetic screwdriver. Now, it doesn't last forever, like if you buy a magnetic screwdriver, but it's a whole lot cheaper. And it's a lot handier at times if you don't have one. You can actually make one. You can magnetize a piece of metal. So light, sound, and energy do not make up matter. What is mass? The amount of matter in an object. Okay? That's our definition that we've had. A gram is a common measure of mass. That's what it's measured in. If you'll notice in science, they start moving away from U.S. measurements, and they move toward the metric system. We are one of the few industrialized countries in the world that have not moved to the metric system. We stay with our U.S. measurements. We don't like them. Nobody wants to go through the transition period. But in science, the majority of what you do will be in the metric system. And the conversion of that is important. Years back, scientists were working on calculations, and they had like a $50 million satellite that they lost in outer space. It drifted away. You know why? Somebody messed up on the conversion from US measurements to metric measurements, and they gave it the wrong signal, and it was lost forever, based on one mathematical calculation, because it was done and had to be converted. So the conversions are important as you move on. Objects of the same size can be made up of different amounts of matter. We talked about a piece of cork and a piece of steel. If they are both 1-inch cubes, which one is going to have more matter in it? Which one? The steel. Even though they're both the same size, one is going to contain more matter and be denser. These tables. If one of these tables is made out of steel, one of these were made out of plastic, but yet they were the same size and all that, which one would be heavier? The steel one, because it would contain more matter. Weight, however, is different. Weight is measured of the gravitational force of an object. Again, we've talked about that before in the past. I'm pretty sure you talked about that in 7th grade last year. Okay, with gravity, forces of motion, and how the weight changes if we are on the moon versus being on Earth. On the moon, I could say I might weigh a slim, trim 92 pounds. Okay? The ultimate weight loss plan is not Weight Watchers. It's taking a trip to the moon, and your weight will change. So the greater the mass of an object, the greater the gravitational force on the object, and the greater the weight will be. But do not confuse mass with weight. They are two different things. How does mass differ? You would weigh less on the moon because gravity on the moon is 1/6 as strong as it is on Earth. Lord, it just got better. I could drop 200 pounds if I went to the moon. I still look the same way. I would still be me, but I wouldn't weigh but 40 pounds. Rachel, Zach, y'all might not even exist up there. Zach, what do you weigh? 80 pounds? So at 80 pounds, Zach would weigh 12 and a half pounds on the moon. So that's why they have to have special suits, okay? Because at 12 and a half pounds, eating a sack of dog food would be way more than Zach. Which ain't a bad thing, bud. Mass stays the same for an object even when increased or decreased gravitational forces change the weight of the object. Okay? Mass does not change. Weight can change. The funny thing is, weight can change on Earth because the gravitational pull on Earth is not identical everywhere. But it's so minute that we don't notice it. Weight is the downward pull of an object due to gravity. Because gravity on the moon is less than the Earth, an astronaut weighs less on the moon, mass stays the same. How are they measured? We use a balance scale. So both sides need to be balanced. It would balance the same way on the moon or the earth. It measures mass. Triple beam balance scales can be used to determine mass. The balance compares an object's mass to countermasses. Weight is measured with a spring scale. We used some of those, I know, last year in the 7th grade. The standard scientific unit for weight is the Newton. Again, most of this is 7th grade review. Mass versus weight, what can we figure out here? Answers on the slide. As mass increases, weight also increases. Okay? On a steady what? Ms. Moss has been teaching about this for a while now. Starts with an S. Slope. Thank you, Kamaya. Steady slope. The spring inside the scale does the measuring, how much stress is put on the spring. How about the amount of space occupied by matter measured? How is that done? What if I've got an octagon-shaped rock? How can I calculate the volume of that rock? Any idea? It's really easy. Okay? Water has a density of what? 1 gram. Okay? So if I take up, volume is the amount of space that an object takes up or occupies. So if I take a beaker of water and I fill it up to a certain point, we're going to see what happens. Two objects may have similar volumes, but do not always have the same mass. Volume measure the amount of space that an object takes up or occupies. An object's volume can be determined by a formula if the object has a well-defined shape. Well-defined means easily measurable. A cube, well-defined. A rectangle, a square, okay, a triangle. For rectangular solids, volume equals length times width times height. Okay? That is the formula for volume of a rectangular solid. To calculate volumes, all measurements must be in the same units. Let's look at the math. What do we know? We know the length is 30 centimeters, the width is 40, the height is 200. What do we want to find? The volume. Now this chart right here are the very same things that we talked about in 6th grade. These are the same things that we've talked about all year long. What is the question asking? What is it telling me? What do I need to do to find it? And it's writing things down in a logical order. It's a recipe. Draw and label. How many times have I said draw? Countless times. Draw it out. Write the formula. Volume equals length times width times height. Substitute what we know. We do the math. We get 240,000 centimeters cubed, or cubic centimeters. The given units are centimeters, and the measure found is volume. Therefore, the unit should be centimeters cubed. Because we did it 3 times with 3 different measurements. So how can we determine the volume? Liquid volume is measured with a beaker or graduated cylinder in liters or milliliters. Now, if we're using a little bitty rock, we don't want to put it in a whole liter worth of beaker. We're not going to get enough displacement. So we want to use something proportional to the object we're trying to determine the mass, the volume of. 1 milliliter of water equals 1 cubic centimeter. The displacement. What does displacement mean? Write the word down. What's the prefix dis? What do you think the word displacement means? Not supposed to be? If you dislocate your shoulder, what happens? It's in the what? Wrong place. It's moved out of its normal position, right? So what do we think displacement means? Wrong place. It's been moved. Okay? Displacement means move. Displacement of water in a graduated cylinder can be used to find the volume of irregular shaped solid objects. Remember the octagon-shaped rock we talked about? Not really easy to find the volume of that rock with our length times width times height because we've got too many sides. How many milliliters of fluid does this object displace? On the left-hand side, where's the water level at? About 35. Right here. Over here, we're at how much? 40. So it displaced how much water? 5 milliliters of water. So if 1 milliliter of water equals 1 cubic centimeter, what is the volume of the object we dropped in the cylinder? $40. Everybody agree with 40? Who has a different answer? Everybody awake? 5 what? 5. Why? 35 went to 40 means it moved 5 milliliters, and 1 milliliter equals 1 cubic centimeter, so the volume of that object is 5 cubic centimeters. $35 milliliters, 40 milliliters, the volume of the rock is 5 milliliters or 5 cubic centimeters. Let's look at another one. If the volume of the rock immersed in the graduated cylinder is 60 milliliters, what will the level of the water be after the rock is removed? Think about that for a second. All right, what's the question asking me? What's the water level after the rock is removed? So, Lauren, what's my current water level? 120, 140, 160, 180. That's what it is currently. Got it. Huh? So, I'm going to take my rock out. How much is my rock? 60 milliliters. So what is my water level going to be when I get done? 120. Okay? So my water level will drop down to 120 milliliters. That's the way they figure out how to build ships and boats. By the displacement of the water is why battleships don't sink. They're made out of steel. Is steel denser than water? Yeah. But the way they design the hull of the ship, how rounded it is, how wide it is, changes the water displacement to where it floats instead of sinking. The meniscus. Now, this is not something that you'll need to know right now, but it's something that will be very important as you move on into high school and college. The water level, if you notice in this beaker, is shaped like a what? Like a U. The water level is measured at the lowest point of this U, which is called in science a meniscus. Now, why does the water not stay level flat? Means water run uphill? No. Gravity's pulling it down, so why is it moving up? The glass attracts the water on the side. Where'd you learn that? Oh, you read my bottom line. Okay? A concave meniscus occurs when the molecules of the liquid attract those of the container. The glass attracts the water on the sides. The glass literally is like a magnet pulling the water, attracting it to it, and pulling it away from the center. But it can create a false reading if you don't read it right. And if you're measuring toxic chemicals and making something, a little bit can change a lot. What is density? Density is a measure of the amount of mass in a given volume. Again, we keep reviewing those vocabulary words and these concepts so that we get it. Okay? The density of a substance remains the same no matter how much of the substance you have. So if I've got a cube of sugar or I've got a room of sugar, does the density of that sugar change? No. The density of sugar is the density of sugar. Now, the volume of sugar that I have, does that change? Yeah. But the density does not change. Remember, we talked about it. Every object has its own density identity. Just like every one of us has got our own DNA identity. Because every substance is made up of different elements from the periodic table. Therefore, they all have different densities. The combinations are not the same. That's why they're all unique and can be identified simply by their density, what a material is. The formula for density is D equals mass divided by volume. Common units for expressing density are grams per cubic centimeter or G/cm3. The 3 is critical because it means it's cubed. We can't leave that off. If you just put grams per centimeter, that changes everything. Water has a density, again, of 1 gram per milliliter. Common sense here, objects with a density greater than 1 gram per milliliter sink, objects with density less than 1 float. Now, have you heard about people being able to float in the ocean? The Dead Sea, full of salt. Can you float better there than you can at Atlantic Beach? Yeah, because the water has a greater what? Density based on the amount of material in it. Fresh water versus salt water, where are you going to be able to swim the best? Salt water, why? It has a higher density. I promise you that there will be people who miss that question. Okay? But salt water is denser. Therefore, it's easier to float in. So the same battleship that floats out in the ocean, if you took it to Lake Michigan, which is freshwater, then it would sink a lot lower in the water, possibly underwater, because it's designed to be in salt water. Here we can see the density of different substances. Air has a density of 0.001. 0.001, which means air is not really heavy and dense. Okay, it's not heavy because it's not dense. Okay, ice, 0.9. Really, really close to water. The ice in the cup does what? But it's water. Ice is frozen water, so how come ice doesn't sink? It's got what in it? Air bubbles, Maury said. Right. The molecules are not as tightly packed in ice as they are in liquid water. Aluminum, 2.7. Gold, 19.3. That's how anybody watch Gold Rush? They use all that water flowing down, and you would think it would carry the gold with it, right? But the gold falls out of the water and sinks because it's 19 times denser than water. How's density determined? Density is mass divided by volume. Again, common units for expressing it are cubic centimeter or grams per centimeter cubed. Water has a density of 1. We go right back to the same thing. Thus, objects greater than sink, less than float. This little triangle would be huge to memorize and have in your notebooks. It tells you how to manipulate the formula. Okay? Here we've got mass divided by density. Density times volume equals what? It's the manipulation of the formula. I would make sure I understood how to use that. We look at this picture here. We've got vegetable oil, water, and corn syrup. Why are they not mixing? Different densities. Okay? Vegetable oil is obviously what than water? Where's the vegetable oil at? On top. So it must be what? Less dense than water. Corn syrup must be more dense than water. Okay? One more, do the math. What do you know? We've got a mass of 239.2 grams. A volume of 92 cubic centimeters. We are looking for the density. Our formula is density equals mass divided by volume. We substitute our known variables. Density equals 239.2 grams divided by 92 centimeters cubed. We do the math and we come up with 2.6 grams per centimeter cubed. Why do you use math? Language there. Per. Zach is on a roll. I'm sorry, Lord. Yes, you have. Thanks to Carol for recognizing your friend. Remember, use your units. If I give you a paper to do and you don't give me the correct units, your answer is wrong. I've seen college kids fail exams because they didn't put the right units. Okay? What do we know? Volume and density. What do we want to find here? The mass. We've got our formula here. How do we manipulate it? Density times volume is going to give us what? The mass. So we do the math, we get 24.7 grams. That is our mass. Like we said, if we've got two of the three, we can always find the third. Again, this is not grams per centimeter cubed. Our unit here is simply what? Grams. Make sure you get it right from what you're doing. An object's weight is the amount of space it occupies. True or false? False. The mass of an object is equal to its weight. False. The volume of a solid can be expressed in units of cubic centimeters. True. An object that floats in water is less dense than water. True. All right, good job. First, you must find the mass of the object. Then, you find the volume of the object by water displacement for something that is irregularly shaped. For a regular shaped object, you can multiply length times width times height. Density is a calculation dividing mass by volume. So are we all clear on these things? Anybody got any questions? Get a grip on mass, density, and weight. Some little cartoon characters. Mass is the amount of matter in an object. It is measured in grams. A bowling ball compared to a beach ball is relatively massive. Density is the amount of mass per unit volume. It is measured in grams per centimeters cubed. A beach ball compared to a bowling ball is not very dense. Weight includes both the mass and the force of gravity acting on an object. It is measured in newtons. A bowling ball on the moon has the same mass as a bowling ball on Earth, but approximately 1/6 of the weight. That is the second time we've heard the difference in gravitational forces on Earth versus the moon, right? What is that measurement? 1/6. That's probably something you need to what? Write down and remember. 1/6. The gravitational force on the moon is 1/6 that of the earth. Alright, so good job.